Alright, well today I'm working on a fabricated upright. So this is where the front wheel would bolt onto the car, and then the suspension would come off of that, and steering of course. There's actually a lot of geometry that goes on in this piece and a lot of concentrated stress, and because of that factory like cast or forged ones tend to crack. So that's why we have this piece that's so big and tough looking. It has a lot of kind of complicated internal box structures, which makes it not necessarily complicated to fit together and make, but definitely time consuming and pretty critical as far as precision goes. So that's really important. And because of the nature of the part, we have to have a jig to build it, so that all the geometry, the key points, are all the same every time. That's kind of critical to have proper alignment and handling. So here we have a double-sided jig so that we can make a right and a left side, respectively, upright. And the first thing you would do is basically bolt this back plate in. That's what the actual hub bearing bolts to. So you bolt that in here. And then we also have a laser cut, you call this basically a clevis, if you will. That would go on here. It's all fixtured in with bolts and spacers, so it's bolted in very strongly. And then we have up top, we have all the laser cut parts. They all have bend reference lines, so we can go ahead and bend all this stuff to what shape it would need to be and set it in. So fitting is very minimal on this, just because it is all CAD drawn, laser cut, and really the fitment just has to do with maybe something like right here, for instance, where there would be a weld, so it has to be chamfered slightly or radiused, so it can fit over a weld that would be already there, and then continue welding it and putting it together. But other than that, they're really neat part to build, and they turn out very nice.